Hello ADP students. Today we're talking about SAT math and the math strategies that are involved. Certainly as we move forward with the class and the curriculum in which we're teaching you, we're going to be teaching you the fundamental skills and concepts on how to solve math and the types of questions in which you may be asked. But however, there may be moments in which you find yourself at a pause or you're kind of stuck or something and you need a little bit of momentum to sort of get you going. And there's two strategies in particular in which you can use to help you in moving forward or maybe solving a problem which is kind of have you stumped or something. One of them is trial and error, and the other one is the backdoor method, so which I'll talk about a little bit more in detail here coming forward. So trial and error, and the strategy involved with this is that it's okay to be wrong when you're using the trial and error strategy. In the choices in which you have A, B, C, and D. And the idea behind this one is to utilize the answer choices because those are the answers and they're given to you. So, and using one of those answer choices to plug in and solve the problem. And the idea is that you choose B or C, kind of depending on how they are and stuff. There's not too much of a discrepancy or too much between the values and things. And then using one, plugging it into the equation, and then see if that solves it and if it's correct. If not, then you know that's not the correct answer and whether you need to go higher or lower in a way. And then being able to ones, if you need to go higher in a number, then you know that the choice A is incorrect if you selected B first, and then so B and A are out, and then it's going between C and D and things. So the idea, in looking at this example here, is that we have this problem. We have this this quadratic equation and things, and we want to be able to solve the value for x. Well, some people and individuals may not necessarily look at this and kind of become stumped in some ways and not necessarily know how they can solve for this. So what you can do is, as I mentioned, a lot of times you're going to see the values go from low to high. And with that, choose either B or C to insert as the x value, since that's what we're looking for, and this is the answer. So a lot of times when you see a question that asks, what is blank and such, and that these are the values here, it's got to be one of these. So we can take one of these, insert it into x, and then being able to move forward. If it does not equal 0, then we know that's not the correct answer, and then we can determine to go high or low from there. So moving forward, we'll try C in this instance. We have our equation, x squared minus 6x plus 9 equals 0. We then inserted C, which was 6, and working this value out. See there, 6 squared, 6 times 6, so we get 36 minus 6 plus 9, and 9 does not equal 0. So we know that C is not the correct choice in this instance. So with that, we have to determine whether we're going to go high or low. And from that, we know that we have a value that was too big, so we probably need to go a little bit smaller so that we can get closer to 0. So again, we have our equation. We insert the value in B, which was 3. Put that in there. We get 9 minus 18 plus 9. And then we get negative 9 plus 9. And then we get 0 equals 0. So in that sort of instance, we've used trial and error successfully, and we know that B is the correct answer because this equation is true. Here's another example of this. It says, what is the value of x for the equation of 2x squared plus 6x equals negative 32? So again, we have another quadratic equation and such. So we have this in which we're looking at it, and then we need to balance this side out with this side to equal negative 32. So we have our answer choices, again, going from low to high. As you can see how the values are. This time try and C again. So write our equation, insert the value of C, keep solving it out. 2 times 16 plus 64. Definitely not going to be a negative 32. So we see that is definitely not a value or choice in which we can use. So kind of going there again, we know that was too large. We know that we need to go smaller in this instance. And then we're trying A in this particular way. So the thing about using trial and error is that you should not have to solve an equation more than twice. If A is incorrect, then I know that B is our answer choice because C was too large, which then therefore makes D too large. And if I try A and A is not the correct one, then we know that B is the correct value. Here we go, inserting the values here. Negative 4, 2 times 16 minus 64. 32 minus 64 equals negative 32, and negative 32 equals negative 32. So that our answer choice is correct. The solution is true. Answer A is the correct one. So last time, trying this a little bit different on something else. So looking at this one is asking the average of 5 numbers is 45. If 4 of the numbers are 20, 19, 48, and 65, what is the 5th number? So we know that the 5th number has to be one of these values, and we know that the average of the 5 numbers is 45. So looking at these, trying to decide on what we have, and go with the try C here. So if we answer choice C, we get 20 plus 19 plus 48 plus 65 plus 45 equals 197. Well, 197 divided by 5 is 39.4, which is not the average of the 45 numbers, is 45. So this is not correct. And we have to look at this. Do we need a larger number or do we need a smaller number? So in looking at this, we determined that we needed a larger number because 39.4 was not at 45 and we needed something more to get us there. So we used these same numbers, 20, 19, 48, 65, and then thus this time used the answer choice 73. Equals 225. 225 divided by 5 equals 45. Bingo. We have our answer choice, and it is correct. So that is trial and error in a nutshell there, and you can see how you can use the answer choices to your advantage, and with that, helping you to maybe solve some additional questions on the test that maybe not have gotten in, otherwise. And if you're doing that once or twice within the test and on a section, that could very well equate to another 10, 20 points and things. So certainly each answer choice is very valuable, and you want to use all the different variables and methods that you can use to your disposal. So let's look at the backdoor strategy. Some things you need to ask yourself if you can use the backdoor strategy. Does the problem have algebraic variables? Do the answer choices have algebraic variables? If yes to both questions, then the backdoor is open for you to use. So more strategies here. Make up a number for each variable in the problem that can be easily multiplied or divided. You'd like to try to avoid using 0, 1, or 2 if all possible. And for geometric angles, avoid using 30, 45, and 60 degrees. You use the made up numbers to evaluate the original expression. So we want to be able to make a number that can be plugged into a variable that will help us to solve the equation or the problem of things. And then from there, being able to see, what's plug in the numbers and the made up numbers into each answer choice. So we're going to solve the original expression, and then once we solve the original expression, then we're going to try to see if that matches up into our answer choice. The correct answer choice will have the same solution as the original problem, correct? And if multiple answer choices result in the same correct number, which sometimes happen, use the ones that it results in a correct answer choice, and then go from there and pick a different number with the ones that result in the same answer choice. I have never seen an instance where you've had to work and solve this out more than once with another answer choice. So here we have this equation, where we're dividing this polynomial of x squared minus 9 divided by x squared plus 6x plus 9. So which of the following expression is equal to the expression above? And we have our answer choices over here, which we see algebraic variables here, and then there's more algebraic variables over here. And you may be like, yeah, I don't know how to solve this. But if we insert values for x, we can solve this, and then take that same value that we inserted for x here, plug it into here, and see if we get a matching value for the two. And if so, we know that they're equivalent. So for instance, we're going to choose x equals 4 in this particular instance. So we've done this, taken our equation, inserted the value of 4, solved it out. We now have 7 over 49, or equals 1/7. So this is, by plugging in the value of 4, we get 1/7. So now we need to do that with our answer choices and see which one of these values gives us. Well, if we do that for choice A, that does not work. So incorrect. Choice B, however, as we insert the value, yes, it does give us a value of 1/7. Choice C does as well, gives us a value of 1/7 though. And choice D is incorrect because of 9. So we know that looking at it that B and C are potentially a option for our correct value. So going through, we'll choose 5 this time, solve this, do the same thing as we did before, inserting the 5 into the place of x, and we get our value of 1/4. So we know between B, we need to solve that. Insert 5, answer choice B gives us 1/4. We do that the same thing for C, our value choice is 1/8. So B is our correct answer, and all we had to do was just make up a value to solve those answers. Usually this is a really good strategy, or what you can use on the section 3 of the test, where there's no calculator involved and you have a lot of algebraic equations and that are being asked of you, especially more advanced ones in regards to like the Passport to Advanced Math. This is also really good for geometry too. So here's another problem here, and we're working with a this one here, problem for advanced math. This is which of the following is equivalent to 1 over the square root of x to the nth power. And here we have our answer choices. So here we had to choose 2 different values, and we chose x equals 16 because we chose 16 because we wanted something nice and pretty. You know, if we're doing a square root, we don't want to make it any more complicated than what it is. So we do that. And then we do n equals 4. So you see we insert our values. We then get 1/4 of that because you're taking the square root of 16, and then 1/4 times 4 equals this value here, 0.0039. So then we take our x and our n and trying to value and see which we have. We do that for A, 256. Yes. Definitely not working for us there. B, insert that one, x over negative n squared, or n2. Insert that, and that gives us a value in which we're looking for. C, do that. Definitely not what we're looking for, as you can see how large that value is. And then D, again, an extremely large value that does not fit our needs. So B is the correct answer for this one. So that is the end of our math strategies. Certainly I hope this gives you another opportunity in a way, in perspective, to look at the problems and trying to solve them. Sometimes solving them straight up in the right way is the best and correct way. Sometimes going through with the trial and error and the backdoor strategies surely can help to save a little bit of time with you. And what I always encourage students, there's usually more than one way to solve a problem, and even the ones in which you're getting correctly, trying to look at them and evaluate them. Can I solve this problem differently? Is there another method in which I can do that? And the more in which you practice these methods, the more uncomfortable in which you become in using them, and with that makes you more versatile when you're actually taking the test and being able to solve those problems more confidently, and just as well as that you know that you have different ways to attack it. So hopefully these were helpful, and during the curriculum and things we will be pointing this out as well and showing you opportunities and problems and where to sort of look for chances to utilize these 2 strategies. So thank you very much, and best of luck.